late Walchand Hirachand. He created an industry with the help of government of Mysore at the time, Raja, and then with an intention to manufacture the aircrafts. He started this Hindustan Aircraft Private Limited. If I have 20 US specialists in front of me and we have 5 or 6 specialists sitting in the opposite direction, if I say it is not okay, it is not okay. When on a technical discussion, you stand up and those guys to stand up. No way we have grown to that level of technical capabilities in the system. If you look at it in the Amrit Kaal, India has a definite edge to participate or create a fifth or sixth generation fighter, right? Whether how do you do it is a different issue.
Good evening to this August gathering. Chairman ICSSR Professor Bajaj, Shri T Suvarna Raju ji, former CMD Hindustan Aeronautics Limited, learned presences in the hall, my colleagues from ICSSR. This is indeed a very happy and proud as well as a privileged moment for us. This moment where we're going to listen to experiences and achievements of Shri T Suvarna Raju ji and HAL from himself, though we know the great achievements, certain indications that Dr. Jain just mentioned. For us in the social sciences, achievements in sciences are very significant and important, not only because any achievement, any innovation in any field of knowledge has certain definite social impact and relevance, but also for the fact that, especially in relation to aerospace, and this is not my area, but as any individual, as any informed Indian individual, it's a matter of pride for us as Indians if there are innovations and achievements in aeronautics, because we keep on listening at times about, let's say, MiG-21 and aircrafts that we buy from other countries, and therefore as a narrative which is to be built for the nation, especially in the Amrit Kaal, it's all the more important for us to recall and celebrate the achievements in the field of aeronautics, both military and civil. I was just a silent audience to a brief conversation that was going on. The fact that cable itself, as such an important, ingredient equipment there, it also is about a smarter and a lot of innovations that's going to happen. And this, so I think I not take the time. We are very eager to listen to you, sir. And on behalf of ICSSR, on behalf of myself and the chairman, I'm really grateful to you for giving us this moment. Thank you so much. Thank you, everyone.
Thank you, Doctor, for giving me and inviting me to give a talk on this. I'm grateful to Chairman Dr. Bajaj and the member secretaries, Professor Dhananjay Singh, inviting me to talk on this Amrit Kaal Mahotsav lecture series on the evolution of aeronautical design and manufacture in India and the prospects for the Amrit Kaal. Amrit Kaal is a period which we are talking up to 2047, where we would be celebrating our 100 years of independence, India onto it. I would attempt to cover the design and development, the manufacturing and maintenance of aviation or aviation platforms in the past, where we are now, and what would be our path to the Amrit Kaal. If you're looking at it, the aviation, the birth of aviation started in the year 1903, where the first successful powered airplane flew at Kitty Hawk, North Carolina. This is where the aviators, Wright Brothers, could demonstrate a platform heavier than air could fly into the air. And that is the birth of aviation in the world. And then followed by various demonstrations by the Wright brothers to various government agencies in US, primarily to use this help to in the war. But during the World War I and II, this aviation improved a lot, and flying machines were created for various purposes. It used to be a pilot used to sit in the aircraft, and then an observer who is sitting next to him with a pistol in his hand, and they used to go over a terrain, and they used to mark how the terrain is, and they used to mark where the enemy positions are. So that's how it started. And then coming up to the World War II, they used these platforms even for bombing. And if you imagine the number of these aircrafts manufactured during World War I and II, you would be stunned. Thousands of aeroplanes were made, thousands of them. And the productivity, if you can believe that, in a day there were 24 aeroplanes were made. In a day, 24. So that is the kind of manufacturing thing was done. But then they were very low in its agility, and the speed was not going beyond 100 miles per hour. But then that is a purpose for them. Either you go reconnaissance, either you go see where the enemy is sitting, either you go see, drop something and come back. So that's, and coming to the War II, where the bombs are being dropped, you know the famous case where the Pearl Harbor bombing. So that's how this aviation, which got an impetus, and then the people realized more than the land power and the naval, but the Navy used to be the more powerful asset. And I mean, it said that the Brits ruled the world because of their naval power. But then this aviation, which has created a niche for it, and then said that this is the possible future which helps the nation to be strategically strong. From then, if you, of course, from the world aviation history to the Indian thing, in India, we had this aviation world, or the aircrafts flying in India was done in 1912, where this Royal Flying Corps of India was created, and then followed in 1918 by creating Royal Air Force, because the World War II is also coming on, the 1 and 2 which are going on, and to prepare and participate, UK used Indian pilots, and they brought their platforms into India and then trained our people and then used them in the war to assist their armed forces. Finally, the creation of Indian Air Force in 1932 has started the era of looking at the platforms which are required for the security and safety of our nation. During this period in 1940, coming to India now, I'll not deal with what is happening outside in the world between these years, but that can be parallelly seen in what's happening in India, because we're looking at how do we look at our Amrit Kaal thing. So I would be talking what was and what is happening and what's going to be the scene in India. So if you look at this aviation in India, industrialists who late Walchand Hirachand, he created an industry with the help of government of Mysore at the time, Raja, and then with an intention to manufacture the aircrafts. His intention was first to manufacture the aircrafts in India. When he found that has a good opportunity, and he started this Hindustan Aircraft Private Limited. And then if you see the the calendar of events which were happening onto it, right? This was taken over by government. And then in 1960, that's where we start. The pressure on India for the neighbors was increasing those days. So it is how to strengthen the Indian Air Force, which is created in 1932. What are the methods which you have to do? So the aircrafts are, the government was serious enough to increase the number of platforms which are available to ease the tension and onto it. At that time, an MOU was signed between USSR, the erstwhile USSR at the time, to manufacture a fighter aeroplane in India at Nasik. And that was named as Aeronautics India Limited, right? And at this, subsequently, we had a requirement of manufacturing the transport aircrafts, which is HS 748. Even today it is flying. So our depot at Kanpur, owned by Indian Air Force, has started manufacturing this transport aircrafts, which used to previously the thing, Dhaka and all, the Dakotas were used to carry the soldiers from here to the Kashmir movement on that. So to replace that requirement, old aging aircraft, the HS 748 was a transport aircraft. It was started. The depot started its work, but ultimately in 1964, Hindustan Aeronautics Limited is formed by amalgamating all these three facilities at the Kanpur, at Nasik, and then Bangalore. Since then, in the 7 decades which have passed, Hindustan Aeronautics Limited, the aviation which is happening in India, is the only one, a place that is the Hindustan Aeronautics Limited, which had the history of 7+ decades of it in manufacturing the platforms which are used in the safety and security and guarding the borders of the nation. If you look at from there, there are more than 4,000 aircrafts are produced, various types of aircrafts are produced. And here we have 17 types of indigenous design. When I say indigenous design, this is designed, developed, manufactured by Indian scientists and engineers. And those days, 14 types of equipment which has been bought in. That means either these aircrafts were manufactured under license or on transfer of technology. Right, so there are totally 32 varieties of platforms which were used by our services were produced in India through Hindustan Aeronautics Limited. These aircrafts need a powerful engines, and the engines are also manufactured under license. Unfortunately, we have only one indigenous engine. The remaining and all were imported. The one indigenous engine also of the capacity of 374 kgs of thrust, and which is used on a pilotless target aircraft designed by ADE, manufactured by HAL. However, we still have a larger dependence of this engines for maintenance also, and not sufficient technology has been gone into that here. All these aircrafts would have, if you take an aviation flying platform, it basically constrains 3 parts. One is the airframe, which is a structure which you see around. Then is the engine. And the third one is the aggregates. Aggregates in the sense, like your car, you have a display, you have wheels, you have brakes, you have lights, and you have a hydraulic system, pneumatic system. So these are this aggregates, we call it, or LRUs in the other word, in the aviation word we call it, it's a line replaceable unit. That means that you pull out this unit and put another unit. It's replaceable unit. So there would be many of them which are fitted in the order of 700 to 800 major components would be fitted of various systems. And there are permanently fitted components on it which runs into 1,000. So the requirement of manufacturing this display, as you said, nowadays the car, you have a smart display in front of you where you get your speed, which gear you're going, and then gives you indication to do this, don't do this, and there is a warning, tire pressure is less. So that's how the pilot who's sitting in a small volume of it, and he gets to know in front of him all the things which are displayed. He lifts his head, and he used to get on the head-up display. He puts his head down, he would look at the head-down display. Okay, and then it should be so clear that when he looks through the canopy or the windshield, that there cannot be any distortion of it. And if you have any, if you look through the water, the coin which would be on a different side. But that kind of an distortion a pilot cannot have, because he looks at it and then he shoots. So the accuracies which the windshields and all these accessories to be manufactured is a necessity. What happens is in any fleet size. Now, I don't think you can or you afford or there is a requirement of more than 100 fighters. We generally take it around 150, except a particular platform which we have in India, Sukhoi 30. No other platform is more than 100. Right? If you have to make 400 aircrafts, these components, now the economics come into picture, whether I make it or buy it. And then it comes into the criticality of it. If it is a critical system, if I have no capability of managing it, then I will do it here. And if I can manage by buying, even if it is not there, depending on the criticality of it, the decision would be taken whether you make or buy. So that's how these accessories are made. And then HAL, or the spread in India, has many divisions to manufacture these kind of displays for various aircrafts which are produced. Now, during this period where HAL is manufacturing onto it, the first aircraft which is indigenously designed by HAL was HT2, Hindustan Trainer 2. This is the aircraft which is created the ace pilots of even yesterday. There's the first aircraft which was built by HAL, and then if you see a few photos of it, I just pulled it from an archive onto the thing, the structure, the wings. When it flew on the 5th August 1951, it could do all the maneuvers. This is not the practice manual. When you take off, first you see that the aircraft is into the air and then you safely land back. But then in 1951 itself, the pilot could do carried out maneuvers including steep turns, stalls, aerobatics. It's something unusual, unheard of it. In my whole career, I was there about 40 years. The whole system, if you look at it, 120 years. I lived in 60 years of it, so that 70% of this is in the knowledge. I could pass through onto this thing. But it was unheard that this kind of a capability which was demonstrated in 1950s itself. That was a capability which was created by our own scientists and designers onto it. From here, if you see what kind of aircraft which are manufactured by HAL, you can see the trainers, which is HT2. You can see the agro-based one, Basant. You can see the fighter Ajit, which was in Sabarjet, which is thrown out. If you look at the 1972 wars onto it, the small Ajit aircraft are a Nat, Holland Nat. Two of them could knock off the big Sabarjets at the time. That is a kind of a capability which is, and those are also from a fallen Nat, this kind of a technology was developed, and the trainers are there. And these are the types of aircraft, fighters, trainers, which more than 100 in 1,000 plus in number were manufactured. And then we look at this rotary crafts. The rotary crafts were primarily from 1960, we have imported this helicopters, which now you keep listening or studying in the newspaper now and then that Cheetah or Chetak helicopters dropped down. These helicopters flying in this country for last 60 years. No country flies more than 30, 40 years. Right? We still, for whatever reasons, don't get into the wrong side of it, but then they are still flying. The more than 400 or 600 helicopters were built in India. But then we came over this restriction onto it. The HAL built the capability of creating unique platforms for India. Where when you look at that recent, these things of China coming on the border, and then you're looking Leh, Ladakh, many times you must have heard and read in the newspapers. Our helicopters have to fly at an altitude of from 18,000 feet. There's no requirement anywhere in the world. Even you see the American things, they operated 14,000 feet. But the Indian requirement is a peculiar because of our environment and the place where we are looking at it. So you have to land and take off at 18,000 feet. So that's the kind of a requirement which is created. We learned that over the last 20, 30 years, the advanced light helicopter, which is an indigenous platform, which is created by engineers and scientists here. The whole of the structures, if you look at this carbon composite blades for the first time in the world, which is made in India, right? So from there, it took about 18 years to make first advanced light helicopter, right? And then it took 9 years to come up with light combat helicopter. Now, if you're looking at this light combat helicopter, which recently in the newspaper, government has ordered around 12 limited series onto it. These are equivalent to Apache if you are looking at it, except one radar which is on the top of it. And the Apache cannot operate at 18,000 feet. Whereas this can take you, because you have to take your ration and people at a given time. God is not grateful to you. Suddenly if you are looking at a hill station where you have to move your troops, you never know when it is cloudy, when it is going to collapse. And given a patch of a time, a half an hour or a 20 minutes or 1 hour, you need to lift the people and the ammunition and ration and everything for the people who are in the guarding this in the frontiers. So that's kind of the development which is done. And I'm sure, okay, from there you look at this light utility helicopter, which is at the bottom. That's the equivalent to the ones which are flying, like I said, the Lama Alouette, which we got it from France. And then this is a 3-ton helicopter, and this is done in 6 years. So first we took, maybe when we come to the fighters, I'll tell you the Tejas, which, any newspaper was commenting 30 years, 3 decades you took to make a fighter. But please understand, with no technology given to us, with nothing known to the Indian engineers, we created a platform which flew in the air within 30 years. We never had any idea about it. Where did we get? Because we were, as a country after independence, we have closed our doors. We didn't call outsiders to come and help us. We didn't call America to come and sit with us and do that. Many people did. But then we ourselves wanted to do it. It took time for various reasons. It's easy to say you took 3 decades. But today, if you're looking at it, a platform which is flown, done, and is guarding other skies. From there, now we are saying what we are talking as an AMCA next series. I'm sure it won't take you 30 years at all. To illustrate that, I'm spending a little more time on this, the ALH to LCH, light combat to light utility helicopter. We are the 6th country in this world we have the capability of it. And it is with the specific requirements, which are unique requirements in this country. Now, when you own your product, you can do anything onto it. When I come to the manufacturing, I'll tell you how it is. So this is a span. Look at what was, what is, the number of platforms which are made from 1940s to the latest to show how the aviation came up in India. So this would give you an idea. You can look at the trainers, you can look at the fighters, you look at the helicopters. Even in the civil, that is what I said in the Kanpur depot where we had HS-748 and the Dorniers. The Dorniers, which are the workhorse for the Coast Guard. Every day morning, 20 Dorniers have to take off to see the coast. So these are the ones which have created. Of course, the engines, as I said, we have a large dependency. I will further dwell onto it later. Systems are need-based we did. And of course, we started supporting the structures which are required for our space. And also we'll be proud enough to put ourselves in the world map that not only for our requirements, we also help other countries to launch their satellites. Now, all along this many platforms, more than 1,000 which have been made, I said 2 ways of manufacturing onto it. One is that licensed manufacturing. That means the OEM, the original equipment owner, either it could be France, UK, Russia, they give you how to do it, right? And then manufacturing through TOT. The transfer of technology, of course, this is also commented in many times on the newspapers that is Indian engineers or Indian industry is capable of absorbing the transfer of technology, right? There's nothing like question on absorbing transfer of technology. The basic thing that these platforms are flying and guarding our nation itself is an example. If I had not understood how I made this aeroplane, how would I support it? So, I mean, that way you should do it. Okay, there could be people who commented, in my opinion, did not know what is transfer of technology. When you are buying from there's nobody says that. Everybody nowadays talk, all other countries, including US, says we want to help you. There is no love lost for Indians, right? It's a business. Nobody gives you the state of the art technology to you. I mean, sometime back when there is there was a talk with all the people. So when I was questioning the US thing, now previously you must have again read in the newspapers F-16, F-18, America is offering us to us on the MMRC and all. I only asked, why are you not offering F-36? Why? I want to pay you money. What I want you give me, but you don't give me what you don't want. Right? That's how the system works. It could be, we can argue in many ways, but it's after all a business. And of course, it's a strategic strength of a nation, and nobody would want to part away with the state of the art technology, which is giving him a muzzle. Right? So it's again, the transfer of technology is limited to the thing what is given by the original equipment manufacturer. We learned over years. We learned over years how to ask more. Right? Today, we were well understood what is the transfer of technology, what should be asked for it. Right? Otherwise, it is dictated by the OEM. It used to say, when we go to the government gives us a CCS sanction of, say, a few hundreds of crores or thousands of crores. They say, this many crores are for you for capital, this many crores are for you for deferred revenue expenditure. Go buy these equipment, 1, 2, 3, 4, 5. These machines which are defined, declared by the OEM, we buy and put it. And he says, you do the component like this. So I turn the component, my value addition in phases. These are being done in phases. We say the first phase, when a transfer of technology is there, for that, not only aircraft, you take anything else, even the imported high-end cars if you're talking about, right? So you get this car dismantled into major parts, and then they come into your industry, you put them together, test them, paint them, and use them. There, the value addition could be about 10 to 15%. And then you go to the next stage where the individual component kits are given. So your value addition is a little more. From a components, you make a door. Earlier, you got the door itself. Now, today, you get a components, outer cover, inner cover, ribs, and then you start riveting, joining them, painting, put the glass up and down mechanism. So that's the stage 2 where you learn little more. Your value addition could be 25 to 30%. And then you go from the raw material. Now, what you do is first the items or the components which are required for you, you start making them. You machine them, you form them, you weld them, you make a final product, and then you go. That's how we made all these 14 types of platforms which are there, like, even the Sukhoi, which were the ones which are flying now. We started from a phase 1 where we bought major wings, fuselage, engine, joined them, flown, painted, and given it, to manufacturing about 44,000 individual components and 700 aggregates, putting them together with 1 million odd components and making the aircraft test, fly, and give it. So this is how fundamentally our manufacturing process has evolved in India. From there, we learned a lot. Now we have good technologies, and we understand what, I've just talked about the phased manufacturing onto it. And this also depends on it. Now, sometimes the question comes onto it. Now, buying is cheaper outside, making in India is costlier. One of the comment quite often looked at it, right? If an F-16 aircraft in the world, those chaps have made about 4,400 airplanes, fighters. So obviously, when he made the first aircraft, he must have taken 100 hours. Let's say an example, if you're using a learning curve part of it, the first one, if it taken 100, the second one will take 84 or 82, and the third one goes on to 66. At the 100th aircraft, you get stabilized. Well, how many Rafales we have got? 32, right? Now, where is 100? Where is 32? Even if you were to make 32, would it be cheaper or costlier? So there are many factors which get onto it. So unless you make them, it may be little costly because again, the wherewithal is to what extent he is going to give you is also a limitation which we have to understand. So that's how we, anything which you bring in under license or TOT has the limitations, right? So these are the practices or the ways which we did in this country, and we came up with our indigenous manufacture of Tejas. Now before, we saw what are the platforms we made, and we also seen what was the method of acquiring these technologies. And at this time, just going out of the phase, I'll tell you what my personal experience as a fresh engineer in 1986 was sent abroad to UK to get the technology for a fighter aeroplane to be self-reliant in India. I've just passed out engineering and then 3 years in HAL, went to UK, and we discussed with them around 20 companies in UK and then around 30 companies in France. I still remember, I can never forget the way they were treated us. I mean, not to take it the bad, they looked at me as though, a kid, you don't understand. He has to show me pencil. He says, you know how pencil. So that's the kind of a feeling I got. So we were asked to buy some items, special tools. Okay, we went to the shop and then looked at the tools. I said, I'll come back to the technician, let him show how to use this. All right, because I didn't understand how they use onto it. I'm also an engineer. We did study on this thing, but the costs were pretty high. So after lunch, no, you come after lunch, the technician said. I went to the technician after lunch. I'll tell you, there is a base plate. In that, there are smaller bearings are put. Now, we need to take out those bearings and put a fresh bearings. Right, aircraft got a very peculiar thing. Either by calendar or by flying hours, we give a fresh life, 00. Right. So I said, how are you doing it? For me, they have told me there are puller, this thing, lot of tools which are put. I went to him, he said, why I have asked you to come in the afternoon is that he was heating the oil pan, put this inside. The base is aluminum, bearing is steel. So he took it and banged on the floor. That's his practice. But for us, it used to be like that. It used to be like that. But then from there, I'm talking about 1980, I was one of the member in this MMRCA team, right from the day one, writing the specification to the last day of its closure. I was the head of the technical team, right? We came across up to this thing and the technical discussions on the table. If I have 20 US specialists in front of me and we have 5 or 6 specialists sitting in the opposite direction, if I say it is not okay, it is not okay. When on a technical discussion, you stand up and those guys to stand up. No way, we have grown to that level of technical capabilities in the system. So before going further, let's understand how you make a platform, right? Either there are 2 variants, and should have told you the civil and fighter version. Civil are the defense. The civil, we have no edge at all. It's again the Western-oriented monopoly or duopoly of Airbus and Boeing. No other has still survived. I don't think this is going to change in the future also. I don't think in India by this Amrit Kaal or anything we attempt to do that. So I'm not touching the topic at all. So it's somebody else who's monopolized. You got to buy, even Air India is going to buy 200 Airbus or Boeing. You go there and buy, and their order book keeps running for years onto it. Now, first on a defense aircraft or a fighter platform, for a use in India, the user gives you a specification. Like the helicopter which is said, the user is Indian Air Force says that I have to start flying from Leh. Now, if you go to Leh, the Leh is at 14,000 feet. So from 14,000 feet, you have to take off. So either taking off from ground, sea level is different, taking off from 14,000 feet is different. So that's how the user gives his SQRs or quantitative requirements. Based on that, we define various systems, how should they work, what its requirement. And then we start doing a detailed design. The detailed design or a preliminary design which we do onto it, and then fundamentally after preliminary design, we go to the customer, we go to the user and see whether it suits or not. When we have a clarity onto it, we'll get into a detailed design process. When we start detailed design process, in that we start manufacturing the prototypes. The prototypes have to be put through their wind tunnel tests and then test flying. And then we get clearances for the production, and we have the national agencies who clear the system. Then the aviation and aerospace is a procedural oriented. It's a process. You cannot skip it. It is 100% inspection. Today, if something happens to your platform, you should be able to trace that component even 15 years later. So from where it came, who manufactured it, which country did give it, what process you did, what dimensions you make. So it's a very strict process oriented. I mean, lucky that if you look at this, we talk in terms of parts per million. Now, how many landings and takeoffs happening in this world? The civil aircraft, the fighter aircraft, millions of them. Very rarely, once in a while, you see something, we lost an aircraft. That too, there would be a reason. But there are not many things to be, I mean, I never heard that this is except the Concorde, which they attributed for a specific reason of a failure of a system. We normally don't hear. It's beyond parts per million. So that's the kind of a quality requirements which look onto it. So it's a very process and procedural oriented. You got to take, I mean, on an average, earlier it used to be said that it take 20 years to design a platform which is worth flying onto it with all its certifications. Today, possibly with the different systems which are there, we could reduce it to 10 years or something to bring it into production. It's not an overnight. It's not overnight. And I like the cars do come in a year. It says the model is over, I'm bringing another model. So that's pretty difficult on it. So this is a cycle which is used in design and development of thing. And then also we came up, because of the long testing period of this product, we do a concurrent engineering. We stop at this testing part of it, preliminary design, look when the prototype meets particular requirements of it, we go in for production. We call that as a limited series production. Right? And as the testing forgoes and then the finally system is proved like Tejas, when you said IOC, initial operation clearance, we made 20 aircrafts and then we took some 2 years to come up to final operation clearance and then and now today you're making 83 aircrafts of final versions. So that's how the concurrent engineering thing also evolved in India to reduce the production cycle times. And then nowadays you have the prototyping where we used to make physically a prototype. When you want to make a prototype, then you have to make tools. Then the question is whether you invest that much money onto it for 100 numbers. So in aviation, we do a wooden tooling. With wood, most of it sheet metal. So with the wood, we make the components for the prototype. And then again, once the prototype is proved, you go down to the metal tooling for the serial production. So that gets avoided when you do a virtual prototyping. When I said we could do it in 6 months on LUH, there's one of the reason because we did this virtual prototyping. We did the wind tunnel models, we did this rapid prototyping models. If you see the bottom, let's say last one is the LUH model, which flew in the wind tunnel to establish what are the parameters which are coming. So these are the technologies now which are available in India for us to create a platform. Once a design or a requirement is given, we should be able to do the thing clear. And also automation in the manufacturing lines. Now, if you look at Tejas wing, which has 4 composite skins, each skin has 800 holes to be drilled. We used to take about 15 days to do the job. And when you do a composite drilling, it's technology, even if a layer comes out, you just can't use the whole skin. So then the requirement made us to invent a method and got a Italian manufacturer to design a machine with a laser marking. Right? You mount this on the jig and the laser marking and drilling would happen. It is done in 8 hours. 1,500 holes are done in 8 hours, which is at HAL also. And then we have a jigless manufacturing. Now look at ALH has, if you look at the Jaguar when you manufactured, Jaguar has 120,000 jigs and fixtures. When you come over the years, from 1980, when you come to 2015, and also the light ALH had about 60 odd jigs. From ALH 60 odd jigs, we came up for the light combat helicopter 4 jigs. We did it on 4 jigs. We started in 1980 LCA. the way we used to calibrate on that is it's a month's job. I mean, every 600 points on the jig to be referred, because the repetition is in the aviation is a must. We call it an ICY, interchangeability. Now you take one wing from one aircraft and put it on another, it should just fit in. There's nothing you have to do it. So that is the kind of a ICY requirements are there. And as we learn this, now when we do a laser marking, laser calibration, all the 600 points are gone. I mean, just keep a laser calibrator here, and then we can do it in 1 hour. So that's a kind of an advancement in automations have come. And these are really existing here. What I'm showing you is from the place where I have, lived for 40 years. I've seen the old one, I'm seeing the latest one, right? And of course, the top one is a moving assembly. If you're looking at the Airbus, the Boeing, there the platform, the structure keeps moving from the platform, one place to the another place. It doesn't stop. Now, today, at 2 hours, it is parking at station 1. Another 2 hours, it will move to station 2. You got to complete your job, whatever has to be done in station 1, there is no excuse. Right? We used to make Airbus doors. Now we are not making HAL. All the Airbus which you fly in, the front doors, every alternate aircraft in the world has HAL manufactured doors as of now. Right? The door goes to the final assembly there. It's a 5 hours job. You take the door, it fitted, yes, thing has to move on. If it doesn't go, we'll be penalized. So that's the kind of advancements which have come onto this thing. And then, of course, these are all going to be used now from here. What was earlier, what is now with this, and now future, what we are going to look at is a kind of a 5th generation aircraft and a multi-role transport aircraft and a heavy this thing. These are the requirements. And the other requirement which we have having currently is the mid-life upgrades. When I'm talking about these platforms, they have a long life. Once I introduce a fighter or a helicopter or a transport aircraft, it stays in the fleet for 30 to 40 years. Right now, if you're looking at today, if I'm introducing a Sukhoi 30, a batch of 12, they're going to be there for 30 years, the life. So the life is by calendar base or flying hours. So what they say, the structural life is 15 years or 12 years or 2000 flying hours. Whichever happens first. Like you buy a new car, he'll say free servicing first, either 500 kilometers or 30 days. The same philosophy on the aviation. This aircraft has to, either you fly, and we don't fly 2000 flights in 15 years. Because, of course, there is no war, but to keep the fleet availability, there are few flyings. The government clears how many flights can be done in a year. Right? Each flight, if you're looking at a Sukhoi, in my days, my estimate was it cost one flight 18 lakhs to fill the fuel, and then you got to be in the air for about 6 hours. Right? So these are, so first what happens is you manufacture today, after 15 years, it comes back to you. Generally, it is calendar-based life expiry. Then you do, instead of doing every day, you do before flying, after flying, night storage. These are, again, as I said, procedurally. You keep on maintaining, checking. The checks are increasing. After 15 years, we strip the aircraft, whatever to be changed. Previously, we started with a hard maintenance. It is 1950s, 60s. So when an aircraft comes like MiG, you strip everything. You strip wings, you strip pipelines, you strip wires, cables, everything you strip off, put them new. Now, today, the kind of platforms which we are making or we are acquiring is condition-based monitoring system. Right? You take your computer there, it says, okay, there is some fault, you pull out only that part. It's not that you bring out everything. So the condition-based maintenance is the norm now. And also now, if you look at the latest, the fighter which we got, Rafale, okay, we have a clause of performance-based logistics. That means we ask the OEM or the man who is maintaining it, look, I want to use, this aircraft should be available to me 77% of its time. If I want to fly 100 times, 77 times, it must be there. If it is not, then you are penalized. If it is more, okay, at my will, I will give you an incentive. So these, in every platform, we get 2 opportunities. After 15 years, we do it, and then another 15 years, we do upgrade, because fundamentally, the structure remains same. the avionics and the missiles and the sensors in the sense, the radar and everything which are there inside, right? In any case, all these machines, the one who detects his enemy first is the winner, right? So these sensors are changing, the electronics are changing day by day, so you upgrade them. They give you twice in their lifetime to upgrade. That means you pass 30 years. And also in India, because of the utility more, we have developed the skill sets to extend the life of the structure. The OEM says it is 30 years, then we do a study, and our engineers say, no, you go another 15 years. So that's why the two helicopters are still flying even after 60 years. Right, this is the thing. Now from here, look at this inventory. Right, I didn't name them, but then you would understand. I will just tell you the philosophy of it. Each one has its life, right? So the entry point of the oldest aircraft, what we have is the Jaguar, would have a few years more. And as you normally listen that MiG-21, so long they are there, they're flying coffins, they should be taken out of it, right? So for whatever reason. So they would be going out of service because they are completing even their extended life. The ones which have come last year or 2 years back, they will stay with us for 40 years. Now you put this from 2023 to 40, they are there with you up to 2063. Right? So that's the kind of a pattern which you look onto it. And also the olden, this thing, then we created our platforms on a dual attack on our country. So both sides. Our strength of this thing is to cater for two people attacking us simultaneously. Right? So that is the main theme under which we have created our air assets. Right? But now today, is that relevant? And the 40s and 50s, when we are created, we need to do a ground attack. So those times the radars were very low, they could not detect. So you take off, the Jaguars are bought for that. You take off 1,000 feet and then go drop a 1,000 kg bomb. The job is over. But today, the Jaguar, the moment it takes off, it's knocked out. I mean, the sensors are like that. What is it? Is it really relevant or not? So the system, how it looks, if you see in the current inventory, if you put onto it over a time period of years 20, 30, 40, 50, 60, some of them are closing out in 30, 40, and the new ones which are there, they would be there available to you up to 60 and beyond. They need to be maintained onto it. But would this be sufficient? Now see this. The aerial lines of the future are going to be entirely different. We're going to talk about missile, S-400 missile cover. The S-400 may pick up any of these aircraft you're talking within few minutes of its takeoff from its base. So we are the ones, the one more system has to come, and then the DRDO, the kind of different missiles and beyond visual range, ICBMs, and then 500 kilometers to 5,000 kilometers. And also we have created the BrahMos. If the BrahMos is fitted on a Sukhoi, if it takes off, it's going to be there 6 hours in air. In 6 hours, the BrahMos can deliver it at farthest point, which is currently a threat. Deliver and return. So that can happen. So what would be the aerial battle lines tomorrow? Are we going to use the manned fighters or unmanned combat aerial vehicles? Are you going to use the missile, these things? And these relevance would evolve as it going. Recently, if you have seen the border skirmishes, how we reacted onto it, and then surgical strikes. So today there is a common command onto it. How the theater defense works out onto it. So still we are evolving onto it. But however, we have the requirement of reaching the farthest place. Whatever we have, but then we look for an aircraft of the 5th generation requirements, where the stealth is higher and not identifiable, and also the sensors which are used onto it. Now, one aircraft which was offered to us can sense earlier days at about 116 nautical miles. There are the ASA radars which can pick you up at 400 kilometers. right? And this this is a requirement which is going to change, and then different systems. Now you can see whether our friends, the capabilities, the reach, the range. Range is the one where you go, deliver, and come back. That's the range, right? And of course, payload is the one how much you carry. I mean, 20 tons you can carry, or 10 tons, or what you can carry. That depends on the platform strength. Further, if you look at it, the aircraft developers in the world are reducing, right? Not many people. Earlier, it used to be a prestige, but many countries started cooperation together. Even if you see Eurofighter, which is created by 5 countries, right? And even the 6th generation fighter, UK is talking to different countries to do it. So the aircraft developers in the world are coming down. Now, but India has a chance. We're having been in this field, if you look at it in the Amrit Kaal, India has a definite edge to participate or create a 5th or 6th generation fighter, right? Whether how do you do it is a different issue. But then we are in the club of this. If you see where India is sitting onto it, now there are only 2 other countries which are making onto it. We did partner with one of this country here to make a 5th generation fighter. For whatever reasons, we stopped doing it. Of course, the other one, USA, is so-called, my personal opinion, you don't get anything from him, right? Even when Obama came and signed 9 these things, even to get a UAV, I don't know whether we could get even a shell of it. That's my personal opinion. So looking at if it could happen, the 36 stealth aircraft, yes. If not, either we join the other 2 or do by ourselves. So far, we have talked about aeronautics, air. Now, the space gets added to it in security environment. This is a very, very vital piece which has come onto it. There are specific satellites which are going to give you information. If you're saying a missile cover or a network, this thing, if you have seen the future in the previous slide, the network, the future aerial battles, all through the communication, the space, right? There are a lot of efforts by different countries on this area. But of course, we are there again in the space. So this is what gives us a capability to be the partner. But of course, the problems come. You define one, whatever the customer is the last one he wants it, but then the designers made this thing. Finally, to the Amrit Kaal, first, as I said, airframe. We do have the capability to manufacture any kind of airframe, right? Now we have evolved, and we have the aircraft structures have seen a 2.2 Mach maximum. Twice the speed of the sound, the structures have withstood. Today, we have the capability of making, even looking at the Tejas and beyond, AMCA, all can make on this thing. Materials, yes, is an issue because of the numbers or the economies. I really don't know, but there's a larger effort by the government to bring them. But of course, our scientists can do any kind of an alloying, but then the virgin materials availability, like a titanium and all, could be an issue, which is required mostly onto this thing. And also aluminum. While we have a giant aluminum manufacturing plants in India, what is required for 100 aircrafts? I was tasked, why are you not buying in India? Why are you going out to get it? So we did that. So 1 day's rollout of an industry would give me material for 15 years. Where do I store? Various issues, but materials availability in India is an issue. Of course, manufacturing skill sets, you need to have exceptional skill sets. We do have on them, so there's no doubt about it. And we are now, we know how to create a structure and how to extend the life of the structure. So the airframe part of it, we're pretty comfortable, and this is a very gray zone engine. We talk of AMCA, which is going to be future 2035. It's supposed to occupy in our services. But if you're looking at a 125 kilonewton engine, which is required for this, no, we are nowhere onto it except one, that PTA engine, small one, 374 kgs, we said. But of course, the efforts are on. There is a 25 kilonewton engine and 1200 watts engine being prepared by, or the test run is going on by HAL. But if you are looking for that futuristic platform which is required by our services during or beyond Amrit Kaal, this one would be a critical issue. The only way out which we could look at this thing is it could be a co-development. If you start and then start doing onto this thing would take a lot of time, the design, development, while our engineering support to the other world is fantastic. An industry makes about 2,800 crores by just analyzing the engine component design for the big companies in the world. But there is no application in India. In India, his business is 50 crores. Abroad is 2,800 crores. So the services we do outside are many. The Rolls, you name that, Pratt& Whitney, Rolls-Royce, GE, these engines, studies and certification or evaluation done in India. The engineers who are sitting digitally, what they're doing onto it. In my opinion, I think it should be a co-development part of it, even though we still comment on the Kaveri. We did make the core engine. We don't see, for whatever reasons, I mean, I'm not blaming anybody. For whatever reasons, from the independent India has never spent 1 rupee for these engines. I do not know. But then we tried from HAL about 1,000 odd crores we are putting onto it and then trying to push this. But then this would be a tougher point onto it. And next comes the aggregates. Electronics, we are there. I mean, all the displays, like he's saying that we did get a display, front-end display from the Indian entities. And there are many people who have developed. I've seen over 3 decades, the small-scale industries have come out. Displays, yes, we have. Hydraulic components can be made, but then the actuators which turn the load, its capability is there, but then we never made any. It requires, the one part of this thing is, this industry is a very capital intensive industry. It requires money and the numbers required are less. And you have a different definition of business in this aviation sector. Unless the civil, which you're making, the Boeing and Airbus, and numbers are numbers. So we are there, but then the more techno-economics is the part of the issue here for be self-reliant onto this thing. So this is where we are. Hopefully, from here, this being a highly technical field, the innovation and disruptive this thing is very less in aviation. While you have an automobile and we have space or atomic power, the disruptive innovations and then technology diffusion is very high. But here in this industry, the technology diffusion very less. I mean, they should be largely they were driven by the OEMs manufacturing suggestions. The technology to the extent which is given was taken, and so we need to have out of the box thinking on this platform, and then we could create the platforms which are required for the future, except well, there are ways and means which we can find out and then do onto this thing. This is what, in my opinion, is the aeronautics in India, past, present, and future up to the Amrit Kaal. Thank you very much.
I first of all must thank Shri Suvarna Raju ji to agree to come here and address a fairly non-technical audience. Suvarna Raju has headed a very large company. We normally do not get an idea of what is the dimensions of a body like an enterprise like HAL. I think market capitalization of HAL today will be 1 lakh crores. 1,60,000 crores.
3 days back.
Okay. And massive revenues, profit of something like 20% generally on the revenue. So we are talking about an industry, and HAL is largely what we have in defense aeronautics. There is other things are coming up, but there's it will take time. Right now, what we have in India is HAL, and it is big. It is not in the aeronautic companies of the world. Of course, Boeing and Airbus are a different level, but it is in the world. It is one of the major uh, manufacturers, designers of aircraft, of military aircrafts. One of the purposes of this series of lectures that we are doing is to inculcate in us some kind of knowledgeable pride, knowingly being proud of what we have achieved in different fields during the last 75 years and what we are likely to achieve in the next 25. And this purpose, this talk in the field of aeronautics has served very well. He has told us, having in 75 years, having 14 indigenous platforms, this kind is not a small thing. Though we do not understand this, it's not a small thing. And maintaining 17 platforms which you have obtained from elsewhere is also not a small thing, because that also requires a technological finesse and technological skills of extraordinary kind. It is one of my regrets, I feel, that we in India, both the social scientists and the journalists, have not paid sufficient attention to what India has been achieving in high technology fields of this kind. When I had the opportunity to serve on the board of HL, and he was the chairman at that time. And when I first went there, some of my colleagues, both in the Swadeshi types and the technology types, both told me that they're really doing nothing. In fact, they get these platforms from abroad, and one of them very graphically put it that they dust down the machine every morning and it flies. One is, of course, aeronautics is not that. Machines don't fly like that. They even if you bought them, they don't fly like that. But when I went there, I was really impressed at the kind of engineering capabilities that have been developed there. And this is another thing we do not understand. Engineering is a very significant, very important skill which modern industrial societies have to learn. And that learning takes time. These things like turning, fitting, machining, welding, riveting, alloying, all these have to be learned. And unless you learn them, you cannot be a significant country in the modern industrial world. And this learning, the world celebrates. I went to the US recently, and if you go to the Empire State Building, and they will give you a whole movie, a whole exhibition on how they learned to put together steel structures, weld them, rivet them together. People are proud of how they did it. I remember I went to Tokyo, and that guide who was taking me around, he took us to the Tokyo Tower, and he said that, the guide said this, that this Tokyo Tower that you see, it's taller than the Eiffel Tower and 60% the weight. And then he said, when we started learning engineering, the engineering in the world had changed. So we learned much better engineering than what the French knew when they built the Eiffel Tower. We don't propagate, we need to propagate that kind of pride in our engineering skills. And that is propagated only when you study what is happening and you talk about it in public. So one of the other purpose of these talks that we are organizing here is that the social scientists, unfortunately, perhaps there are not many who have come, but the social scientists should start looking at these issues. These are significant aspects of India, important aspects of India. There are social issues which one should attend to, but these technological issues are also sociological issues. They also need to be attended to because when you want to learn engineering, basic engineering of the kind I was talking about. I remember when Pokhran happened, I heard Raja Ramanna I think twice talking about it. And half of his talk used to be how in the BARC, they went about perfecting the skills of machining, of riveting, of welding, of alloying. Because other things will not happen till you have these basic skills. And learning of those skills, nurturing of those skills is a great management. And he knows how to do it. And I know, because I know the kind of respect given to the master fitter, the kind of respect given to the master designer. They are not engineers. But engineering runs on those kind of people. Even when you are doing much of engineering through the modern CAD/CAM kind of systems, still you need those kind of people who have mastered the skills. A master designer, a master fitter, a master turner. We need to celebrate them. And we have to document how these skills are nurtured in our organizations. We are doing it. It's not that it's not being done. BRC does it, ISRO does it, and we have held talks on this. HAL does it, BEL does it. They do extraordinary design. But there's not sufficient awareness of it in the society, and certainly there's not sufficient amount of interest that the social scientists are taking in it. Those taking that interest is important for reaching the goals. We have set up the goal of becoming an advanced nation at the end of Amrit Kaal. If we have to achieve that goal, our engineering has to, of course, improve. It is keep growing. And as he has told you, we have plans for that. But our understanding of engineering at the societal level, at the level of social scientists, has also to improve, because unless you start taking pride in these achievements, and unless you start documenting these achievements, it is difficult to keep growing them. Because to a large extent, policy making depends upon what is the perception in the society. If the perception is that they are just dusting these flying machines, then that also becomes an input into the policy making, so that perceptions have to be improved. And I can tell the social scientists that when you start working on these issues, you'll be doing very good social science. Because looking at how in various organizations, how the culture of engineering is created, how that culture is propagated through generations. That day, the former chairman was telling us how Sarabhai insisted on a certain kind of culture being created, how that culture could become enterprise-wide. These are large enterprises, to be able to ensure that that culture is followed at every point of that enterprise. That needs certain design, the social design to do it, and how it is propagated from generation to generation. Those are excellent things, excellent social science subjects, excellent social science problems to be studied and looked into. I hope that through the ICSSR, we will be able to start some effort in these directions. But when you have this kind of large industries, they spawn also a large base of accessories and small and medium enterprises. So Swadeshi is not only at the small and medium enterprises. Swadeshi, this level of small and medium enterprises is also nurtured by indigenous efforts at the larger scale. We have at least two people who have here today who have contributed to different accessories for the kind of work HL is doing. This former director of CSIO, Central Scientific Industrial Organization, and we used to hear that same kind of stories about CSIO when we didn't know it. They developed this glass displays, which was a major upgrade to the cockpit, if I'm right. And but HAL couldn't have done it on its own. You needed people who specialize in this. And I have my friend Rahul Singh here who developed the Teflon coated wires which are used in the this aeronautical engineering is a very, very special game. You have large when you're doing machining, you're making an airframe, you have very large jobs to machine and turn on, and you have very tight tolerances. You have huge jobs which have to be machined to perhaps micron level. And while you are doing this, you also have to be aware that whatever you're doing, much of it will work at very high temperatures and extremely high pressures. And these wires, which control, say, jet engines, they have to work in extraordinary kind of environment where pressures are very high, temperatures are very high. And those specially coated cables have to be made for those. And it was this Garg Associates, their founder, he started learning this technology from scratch. I remember when he used to sit and mix this Teflon, how will it get coated on the wire, how he used to draw the cables. And they're amongst the world leaders today. They supply HAL, but they supply also Pratt & Whitney even today. That kind of, when you have big industry coming, you also have the smaller indigenous industry coming up. And so if we want to do Swadeshi, and that's another of the objectives that we have fixed for ourselves for this, that we will get out of this mold of slavery. When we want to become an advanced country without having to depend upon others, we have to begin celebrating, begin documenting, begin studying what we have achieved so far in various high technology domains, and how the smaller enterprises, smaller Swadeshi entrepreneurs have contributed to this effort. This is also something which we are trying to study in the ICSSR, but ICSSR is an organization of the social scientists. So whatever I'm saying is meant for the social scientists to raise their game, to come equal to what we are trying to aim for in the Amrit Kaal of this great nation. Thank you for joining us today. Thank you very much. And thank you, Suvarna Raju, for